Okay, year 11, let's have a look at now what we were talking about earlier a little bit about roots and zeros. So when we talk about a polynomial or any function, if we put a polynomial equal to 0 and we find the values of x that satisfy that, we call that the roots or the zeros. Now we've already talked about roots all the time when we were graphing quadratics and graphing cubics and things like that. The roots are just where the curve crosses the x-axis. They're the x-intercepts. And the way to do it is just to put the polynomial equal to 0 and solve. Now you will not be asked to solve anything greater than a cubic. You might be asked to do a cubic or a quartic, that's a power degree of 4, but only if you can factorize out x squared or x and end up with a quadratic. You're really only supposed to be able to solve quadratics. But let's have a look at what happens when we have a polynomial. And we'll go down here to some of these. So when we sketch a polynomial, and here's a quartic, you need to understand some things. So the degree tells you what's happening. So if you've got p of x and you got ax to the n, if n is odd, like a cubic, like a 3 or a 5 or a 7, the curve, the polynomial will look something blah, 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 like that. It depends on the number there. So if it's a cubic, if n is 3, we already know it could look like that. Or it could have 2 lumps. A cubic could look like that. If n is 5, well, if n is a number 5, it could look like that. It could look like that. It could have 2 lumps. It could have that. And you're thinking to yourself, it's always going to start and finish going that way. If it's a negative, like if there's a negative a there, a negative cubic, well, we know a negative cubic can look like that. It can look like that. And if we increase the power, we can get more things happening. But in essence, it's going to start up to the left and end up going down to the right. So any polynomial will take that shape if n is odd. If, however, n is even, so 2, and by the way, we're disregarding 1 because 1 is just one is a straight line. So yes, 1 does that as well. If 1 is you can have a straight line. If it's a positive, it's a negative straight line if the power is 1. So if n, however, if n is even, well, we already know the quadratic goes like that. If n was a 4, we can get a quartic. It could go like that. Or indeed, like this one over here, it could go like that. It could go like that. But it'll always start from up here and go back to where it came from. If n is a power of 6, it could be like this one, this one, this one, this one. But we know that it's going to come from up here, do some stuff, and go back up there. And if it's negative, if there's a negative in front of the x to the n, so like negative 2x squared, it's just going to be upside down. It's just going to be one of these things. All right? So it's important to know what these things are going to look like. So let's go down here and have a look at finding roots. So questions 7, 8, 9, 10, 11, 12, 13, 14. I particularly want to look at 12 because that's the big one. With question 7, if p of x is going to be monic, well, then a plus 1 has to equal 1, which means a equals 0. If the coefficient, so they're pretty easy. If the constant term is -1, well then c plus 5 must equal -1. If the leading term, so I'm going to let you do those. They're pretty easy. If you're having trouble, send me an email. All right, let's have a go. I'm going to have a go at 8, and then I'll jump to 10, 11, and 12. You should have a go at them. So 8, what have we got here? We've got p of x equals 2x plus 5. And q of x is a quadratic, equals x squared minus x minus 2. Find any zeros of p of x. Well, we put 2x plus 5. So here's a. Zeros when 2x plus 5 equals 0. 2x equals -5. X equals -5 on 2. Now, the roots of q of x. Well, that's a quadratic. So x squared minus x minus 2 equals 0. What multiplies out to 2 and adds up to -1? Well, I reckon that's x minus 2, x plus 1. So that means the roots are x equals 2 and x equals -1. The degree of p of x plus r of x. Well, if I add those together, I'm going to get p of x plus q of x. Now, I already know the degree. I don't actually need to go through the addition, but I'm going to. So it's 2x plus 5 plus x squared minus x minus 2. Now, I knew the degree wouldn't change. It gives me x squared plus x plus 3. So it has the degree of 2. Hold on. Sorry, I forgot r of x because I forgot there was an r of x in there, and r of x is x cubed plus 9x. So it wasn't p of x plus q of x, it was p of x plus r of x. Was it? Let's make sure I get the question right. P of x plus r of x. It won't change it, it'll still have a degree of 3. So 2x plus 3 plus x cubed plus 9x, is it? Which gives me x cubed plus 11x plus 3. So the degree doesn't change, the degree of 3. But when I multiply them, p of x times q of x. So d p of x times q of x. Well, that gives me 2x plus 5 times x squared minus x minus 2. Now, I don't have to do the whole division. I just need to look here. The whole multiplication, I mean. Those two terms will be the highest term. That's going to be the highest power of x. I'm going to get 2x cubed. I'm going to get a whole lot of other things. So it also has a degree of 3. Now, if here the leading term of q of x times r of x, so e q of x times r of x. Now remember, all I'm looking for is the leading term. So it's x squared minus x minus 2 times x cubed plus 9x. Now you can go and do multiply all those things, but the leading term is going to come from those two. And x squared times x to the 3 is x to the 5 and a whole lot of other things. So the leading term is x to the 5. So don't do the whole multiplication when you're doing these ones. So when you do, for example, 9 and you're doing those ones here and this one here, don't do the whole multiplication, just do what you need to get the answer. So let's have a look now at question 10, because there are a whole lot of polynomials here. How many real roots for each polynomial? So these are going to involve just factorising or looking at the discriminant if it's a quadratic, because we just have to work out how many. We don't have to actually work out what they are. We don't have to work out what they are. So in the first one, x squared minus 9, I know that's going to have two real roots. All right, I can work it out. So x squared minus 9 equals 0, x squared equals 9, x equals plus or minus 3. But they just want me to work out how many. This one won't have any. How do you know? Because I know that that's x squared plus 4, and it looks like that, going through 4 up there. So that doesn't have any real roots. Now you can say, oh, I worked that out graphically. I could work out the discriminant. This one is going to have two real roots. I don't even need to find them because I know it's a positive parabola. So C, it's a positive parabola, and it has a y-intercept of -7. So it must go below the x-axis somewhere. So it means it has two real roots. This one I'm not sure about. This one I don't know. So what would I do? I'd probably pull out the discriminant. And the discriminant equals, so for D, b squared, it's 1 squared minus 4 times 2 times 3, which is going to be 1 minus 24, which is -23, which is less than 0, no real roots. Do the same. You don't need to do it for E because you know it's a positive parabola and the y-intercept's -2, so it has two real roots. And this one, because it's written in factorised form, that's a root, that's a root, that's a root, and that's a root. That one has 4. Righto. Now, I don't want to be doing these for you. You need to go and have a go yourself. So here, when you get to question 11 and 12, I want you to sketch them. So I'm only going to do 2 of these. And note, they're jumping between the different terms now. So here, in this one they said roots. Here they say zeros. And here they say x-intercepts. They're all the same thing. They're all the same thing. Roots, x-intercepts, zeros. They're just where it cuts the x-axis. So 11. These are pretty cool because they're written in factorised form. So I'm going to do C and D. All right, D is important, and you should remember something from what we did before. So let's get myself up an axis. And let's look at C. It's a cubic, and it's a negative cubic. So C, question 11C, this thing is going to go down like, that. It may have lumps. In fact, we know it has lumps because it has 3 intercepts or 3 roots. So where are they? Well, at x equals 0, at x equals 1, and at x equals 3. So we've got 1 here, 1, 2, 3. 1, 2, 3. Now, it's a negative, which means it's coming down here. It has to turn around somewhere to go back through 1 and turn around to come back through 3. So we know that one has lumps. You at this stage don't, so there are my 3 roots. You at this stage don't have to find these things, these turning points. We will later on, but not at the moment. But as long as you know the shape, the basic shape, what was it? Y equals, it was negative x, x minus 1, x minus 3. So when you're doing these, again, that'll be a cubic. You need to know it, and you've got the roots. Here's another cubic, and you know it's a positive cubic. This is a cubic. I'm going to do it in a minute. This is a cubic, and it's a negative cubic because they've written this around the other way. All right? But I want to do D. You go and have a go at those other ones. I want to do D. So I'll get myself up a axis. And what's the equation for D? X plus 2 squared. X, P of X. Oh, come on. Let's make this good. P of X equals X plus, what was it? 2 squared. This is where you've got to be really smart. Here, you must realise that that's a double root. It's a turning point. So this thing has the root at x equals 0, is that one, and at x equals negative 2. 1, 2. It's a positive cubic. When I expand that, I'll get a positive cubic, so it's going to look like that. So what's it look like? This one is a double root. It's a turning point. So it comes screaming up here, hits that, turns around again, and goes up there. It's probably a bit steeper than that, and it's not symmetrical. It's not symmetrical. So, and that's what it looks like. And you should label negative 2, negative 1, label your axes, y, x, and label this curve, y equals x plus 2 squared. Okay, what about these ones? Write each polynomial as a product of its factors, then sketch it. So this is one step more than what you've just done here. You have to write these like that, and then you can sketch them. So let's create a bit of space. And again, I'm not going to do all of them. I need you to have a go at some of them. But remember, if you're having trouble, just send an email. So I'll do 2 of these as well. I'll try and do a quartic and a cubic. So I'll do D and E. All right? You've got a cubic there. You've got a cubic positive, cubic negative, quartic positive. I'll do C and D. You see if you can do E. So here's 12C. The first thing I have to do is I will write the polynomial, P of X equals x to the 4 plus 3x cubed plus 2x squared. Now straight away, it's a positive quartic, so it's going to come down, do some stuff. Oh, sorry, too many lumps there. Come down and go up. It may have two lumps, it may have one lump, I don't know yet. So I'm going to write it in factorised form. So P of x equals, I'm going to take x squared out, and I'm going to be left with x squared plus 3x plus 2. So I've got x squared. Now, x squared plus 3x, I can factorise that. What multiplies out to 2 and adds up to 3, or 2 and 1. So x plus 2, x plus 1. And now it's written in factorised form. The roots are x equals 0, x equals -2, and x equals -1. But look carefully, that's a double. It's a turning point. Okay, let's get our axes. And what do we need? We need 0, -1, -2. We also here, oh, we don't, so we know that the one at 0 is a turning point. So it's going to come down. It's going to go through -2. It has to come back and go through there. And then it has to hit there and go back up again. Because this is a double. So label your axes. Make sure you've labelled your roots. 0, -1 and -2. Label your graph. Y equals x to the 4 plus 3x cubed plus 2x squared. And go to Desmos and see if it actually is right. So we'll get rid of some of these. And what do we have? We had y equals x to the power of 4 plus 3x to the power of 3 plus 2x squared. And there you can see it. And if we bring it in, and remember when I said that you're not meant to sketch these to solve things graphically. Even though mine resembles the shape, it's not anywhere near as good as that one. And if you look at Margaret, the textbook, their answer isn't like that as well. Whereas this is a proper graph. Okay, I said I'd do 12D as well. So 12D, and then I'm going to let you go, and you can email me any questions that you have. So 12D. Now 12D is a cubic, and it's a positive cubic. So in your head, you should be getting your ideas about what sort of shape it is, how many lumps or turning points it'll have. Here we go. So 12D. Note they changed the letter, doesn't matter. A of x equals 2x cubed plus x squared minus 15. So let's take out an x, and we get 2x squared plus x minus 15. And this requires and I chose this one particularly because this requires a bit of work in factorising. So I do 2 times 15 and I get -30. And to factorise this, I need to find two numbers that multiply out to 30 and add up to 1. And I reckon that's going to be 2x squared plus 6x minus 5x, because they multiply up to 30, which will give me x. And I just factorise this first one. So I'm going to use two sets of brackets. So I'm going to make the outer brackets actual brackets. And I'm going to take out 2x. Oh, haven't given myself enough room. 2x, x plus 3. And here I take out the 5 and I get x plus 3. And then I write that as x plus 3, 2x minus 5. And then I can dispense with the square brackets, x plus 3, 2x minus 5. So let's draw our axes. I'm making it a bit bigger for a reason. I don't know if you noticed, but the y-intercept is negative 15. It goes all the way down to negative 15, whereas I'm going to have x equals 0, x equals negative 3, and x equals 5 on 2. So the roots, x equals 0, x equals negative 3, and x equals 5 on 2, 2.5. So 0, negative 3, 1, 2, negative 3, 1, 2, 3, 2.5. So there are my roots. And I know it's going to do something like that. But can't have a... That must have been 15x. It doesn't have a y-intercept of... Yes, sorry. It doesn't have an x-intercept. That's 15x. That's my fault. I wrote that question down incorrectly. So here we go. So it's going to come up, go through there, turn around, go through there, turn around, and go through there. Label your axes. Y, x. Label your graph. Y equals, what was it? 2x cubed plus x squared minus 15x. 2x cubed plus x squared minus 15x. Double check on Desmos. Y equals 2x cubed plus x squared minus 15x. And you can see that even though I have the same shape, it's a lot steeper. It's a lot steeper. And if I look at the answers for question 12D, they've got the same. So don't be fooled into thinking that you've got the exact graph. You'd have to plot some points to get it. So this, in reality, this one goes way up there, way down here, and up there. That's really bad. That's a bad drawing. Okay, you have a go at the rest of 12. This one here, look at it, double root, and it's a quartic, right? Double root, and it's a quartic because you've got 1x there. Come on, where's the pen? 1x there, and 2x's there, so x times x squared times another x squared, x to the 4. So that's going to be a quartic. This one, they want you to do this expansion first. They want you to expand that and show that it equals that, and hence sketch it. So good luck with that.